Henrik,
Sure.
are the robots and AI taking over people's job?
So I think it's not a simple question. So I think in general, if we look at it, robots are entering more and more into our life. The statistics that we have is that when we use robots, we actually also create more jobs. If you look at the other side of it, the I think there's many white collar jobs over the next 5 years that are going to disappear. All the simple stuff, legal assistance and sort of taking minute notes from meetings and stuff like that, that's all going to go away. So
Writing.
the simple sort of unskilled labor is in great risk of getting replaced.
Um, wow. But in the same time, is that it's going to fall the same thing with the art and writing? Um,
So I think there's a lot of writing where you can do drafting and you can use AI for doing this so that you don't have to actually you can get early drafts out and then you can go in and do it. I think for arts it's harder because I don't want to buy art that's created by AI. I want to create art that's
yeah,
actually an expression of artistic things like that. So if you say, "Oh, this was painted by a computer," I'm like, "Okay, sell it to somebody else."
agree no more. Absolutely. Like feel that the art, they put the talent, the soul
The
to an
creativity.
image and creativity.
Yep.
It represents something tied to a
Exactly.
human
Right.
and not generated by
Right.
AI. Which AI is also good how to manipulate things to give you some emotions,
Yeah.
but
Yeah.
still not the
Right.
person. Now,
But there's no doubt we will see we're seeing this with creation of fake images, with creating of new music and things like that. So it's we are used to this, and we're sort of. But I think there were potentially a generational issue where younger generations are going to say, "Oh, this is really cool," and so we'll have to see.
nice, nice. Now I want to put you in a time machine.
Sure.
Go back in time. Where was the first time you were passionate about robot and you decide I want to do this, I want to do robotics to the next 40 or 30 years? When did that all started?
So it probably didn't start really with robots, but I got sort of interested in mechanical stuff and that. So if you go back and ask my parents, when I was young,
Mm.
I would take everything apart and put it back together. And they were worried. So they had pictures of me with my grandfather's
Oh,
milking machine, and I would take it apart, and he
oh,
was like, "Oh, is he going to be? Am I going to be able to milk my cow at the end of the day?"
wow,
So I was probably 4 or 5 years old.
wow.
So it was a long time ago. I was very interested in mechanical systems. Then I got very interested in electronics. So I was the youngest ham operator in Denmark. So you can get a ham license when you were 15. When I turned 15, I got my ham license.
Yeah, okay.
So I worked in electronics and all of this. And then eventually I got into engineering. And that was sort of when I said, I need to go and build robots.
Wow, wow. And when was that? Like, what age was that?
So I was what 19
Wow.
or something like that. So yeah, so it was a long time ago.
Wonderful. Like now we see a lot of young kids today. They're passionate about that's what we do. We do here like some outreach,
Yep,
inspire others, and
yep,
we see those young age starting from. We see some. We do all range of outreach, kids and middle age and middle school and then high school, and we see this passion about
right,
robots, and that could be
right.
really very inspiring.
No, so if you, I'm super inspired by there's something called the First Robotics Competition,
Mm,
where you can go in from you can do kindergarten to high school, and so there's a Lego League, there's a Tech League, there's a First Robotics League. We have about 100 schools locally that actually participate in this. And I say they will solve problems that you don't want to solve.
mm.
So first Saturday in January, they will get a competition. So they will get a challenge and so to say, could you build a robot that can play basketball? And then they have 5 weeks to finish this. 5 weeks.
Wow,
So they know nothing about what it
wow.
is first Saturday in January. And mid-February, they have to hand in theirs, and then they go to competitions and compete against other teams. And it's regional. So we have a San Diego regional, then there's a California, and then they can go to the World Championships. Today there are two different championships, one in Texas and one in Detroit. And these kids go, and if they win, they have tuition paid for college.
Oh,
So big motivation for the parents.
it is.
Can I get my
Yeah. Oh, it's perfect for me. Yeah.
should get your kids?
Yeah, I know. That's awesome. That's awesome. Back, we're still in the back time.
Sure.
You worked in that early time with robotics, where ROS doesn't exist, robot operating system, not a lot of sensor. And the other day you were telling me you were building your own operating system, and you have 256 kilobyte of RAM. How did you get those things moved? How do you even have got those with these hardware constraint and very minimal hardware to even build the robots compared to today's, like, very, we have many sensors, frameworks, and hardware, and with reasonable price. How we made those things happen?
We didn't know there was an alternative. So we got 8-bit processors. We got, actually, I was thinking back about it last night. My first computer had 64 kilobytes of memory. And no, more. There's more memory in my watch than there is in those computers. But that was the constraints we had, and then it was more. You could sort of say that's not enough and give up, but that was not an option. The option was, with the tools we have available, how do we build robots? How do we do something interesting? So it was just, and then of course now it's grown so that people don't have, for many cases, they don't have to worry about this, but still. So I was on the team that developed the first autonomous vacuum cleaner, actually 5 years before the Roomba, and our hardware budget was $200. Wow. So it's more, if I compare it to the robot you have today, for $200, I probably don't get the cover.
Yeah, not even that. Yeah,
so
not even that.
That's important. But for a lot of commercial products, that's still important. We have to sort of think about how do we make it cheap enough that we can do this.
Wow. This is impressive. Now, out of all projects you have worked on before, what is particularly a project that you remember for long, or was like one of the best project that you worked on?
So I probably have two. So one of them is the vacuum cleaner, the first vacuum cleaner, where we said we're going to build a vacuum cleaner, we're going to make it cheap enough that it can get into regular people's houses and drive around, and it has to be safe, it has to be all that. It was incredibly hard to do. So I had, I at the time I was a professor in Stockholm, and they came to me and said, we want to do this. And I showed them sort of my code, which was written in MATLAB. And the CEO of Electrolux said, yeah, that's impressive. You have $200. And I'm like, okay. Had to completely rethink everything to get it to a level where we could actually do it at the cost that was required, which was a lot of fun, but it was a very different problem. The other thing was I was part of the team from Georgia Tech that was in the DARPA Urban Challenge. This is the scariest things I've ever done in my life. Imagine, we had a Porsche with the entire trunk was filled up with compute power. So we had an entire sort of computer rack in the trunk of the car and driving around. And of course, there could be nobody in the car. So you put in a USB stick, gave it the coordinates, you pulled out the USB stick, and the car took off, and you were sort of like, please come back. And, the car was a value of $500,000, something like that in terms of that. That was just scary. What if it doesn't come back?
Yeah.
What if we have a problem? But it was extremely rewarding. So we were a team of 10 people that did this. So it was a joint SAIC Georgia Tech team. And it was just, we learned so much about not, how do you do autonomous driving, which is what you see in Zoox and all of these Teslas and all of those cars today. So it's over 15 years. It's gotten from early prototypes to real world impact. And it was fun to have been there from the start.
Oh, that is absolutely awesome. Awesome. So to big scale, you start with the $200 that you made it happen, Roomba, to
Yep.
oh my God, a couple $100,000, $300,000,
It was
maybe.
so
Wow.
compute power and everything. We were fortunate enough. We worked with the Georgia Tech Research Institute, and they just have amazing engineers that would build stuff that we would like. Okay, this was this was amazing. So it was fun, and having that experience, what was just it was a lot of work. So every Saturday, we had to go down to a racetrack and drive it because we couldn't drive it on the public roads, of course. So we had every state has sort of a police training facility. So every Saturday and Sunday we had free use of the police training facility in Georgia, and we would go and drive on their test tracks. It was a lot of fun, but it was also a lot of work.
Yeah, I had bet a lot of work. Nice. Thanks for sharing those. With the time machine now, we sit in the time machine. We head back now to today's
Sure.
this time machine, and now you're probably gonna guess it. The next question is, with the surge of LLM, large language models, and VLA, vision language action models, which is type for robots, do you think these LLM, VLA, or VLM will become the cognitive layer for future robots?
So I think
And I know the word cognitive is a bit big.
no, but that's fine. But I think it's more we have to sort of think about the robots we've built until a few years ago was sort of it was very basic, the cognitive layer, the level of understanding of people. So it made it hard for people to interact with those robots because the problem is that, when people, for instance, build humanoids,
Yes.
we project intelligence onto, so it's smart as a human. And you realize the IQ is 10 or something like that. And you're like, okay, now a really dumb robot.
Uncanny Valley.
Exactly. So now we're getting to a point where through modern AI, we can have much more of a dialogue with the robots, like the robots you're building. We can go in and it becomes a companion.
Right.
Much more of a companion. It allows you to sort of say, could you go and explore that building over there so I don't have to go into the building? So it very much becomes that. And I think we will see this. We will get much better models of you as a human. I will understand how can I work with you and how can I be much more collaborative, and we don't have to rely on for the Navy, for the warfighter, to have to worry about does the robot, what do I have to do to understand the robot? The robot will understand you. It'll understand scenarios. It will understand enough that it will become much more of a partner, which I think is very important for us. At the same time, I think it's important to take a pause and think about these modern AI systems have only been around for 3 years. So I'm saying I think about AI as becoming the new electricity. It's going to be everywhere, but it's going to be like a marathon, and we're still in the first 100 meters.
Okay.
So if people put in all their energy early on, then that's like if you start a marathon by doing a sprint, you might not make it to the end.
Right.
So I think we have to sort of be careful about how and when we deploy AI, because otherwise we might run out of energy.
Yeah. And thank you very much for pointing out that some people, they don't know that the project that I'm working on, which is we have one of those Boston Dynamics robots, legged robot, companion robots.
Right.
We're trying to make them not only autonomous but also intelligent, adding an AI capability for easy interaction, and which absolutely with your guidance that work on this.
And I think by using the LLMs, you can, in some sense, train those models using the concept of operations, for instance, for urban interventions. This would allow the robot to become much better. It understands when a soldier does a particular hand symbolism, that I know what he's talking about. I understand the group dynamics. Like, I used to do some experiments with the Swedish military. And if, for instance, you're going in and you're searching through a building, you have one guy opening the door, you have another guy standing with a gun, and you have somebody standing in front of the door. The guy standing in front of the door is like, "Can I please be replaced?" And that's what we can do. We can do this where we can use the robot technology, like the robots you're developing, to get to that point where the exposure we have for our personnel is minimized. And at the same time, it's not like, oh, they're slowing me down. This is a really bad robot. Now it's the natural partner of a team.
Right. That goes back to the dull, dangerous, dirty task, the 3D standard task they were challenging for humans, that which circle back to the point that, yes, there is some jobs we as a human, we would love to be replaced.
Yeah.
No one to be the person standing on the door to take the first shot.
I'm sorry, no.
No one wants to be that person to go in the minefield.
Yeah.
No one wants to be that person if you go for some dull task over and over, and you probably long term you will have some enjoyment displacement or some mental issues. Yeah.
But at the same time, that's why that's also why I think it's important for the kind of systems that you're developing. Once we get to a certain level sort of competence, you should take it to Camp Pendleton, put it in the hand of one of the Marines out there and say, you go look at and then they can look at it and say, oh, really? That's the ultimate test.
Yeah.
Is it, it's great, you're a smart guy, you're almost at a PhD.
Yes.
The people out there are not people with a PhD. It's people, in many cases, the people we have as Marine went straight out of high school.
Right.
That's the people we have to be able to empower, not the fact that people that has an engineering degree or a PhD or something like that, they are, and they're very different. So if you look at it, the average 20-year-old American today, independent of gender, has spent 12,000 hours playing computer games.
Wow, so he's already trained.
So they, this is built in, they know exactly how to do this. Whereas, I tried the first time I went out with a soldier and with one of those, he could tell that I was, when the orange button is what?
Yeah.
And he would like, give it to me.
Give it to me.
And then he drove away, So that's what we need to have the expertise to understand. What are their competences? What are their missions? What are the ways in which we can make them safer and more comfortable?
Absolutely. That's it's now these days we need to build things not just for us, but build it for the people who are going to use it, because it might be easy for us because we spend so much time interacting with it, but for them it has to be intuitive, easy to use, as simple as some human level command or some joystick or video gaming stuff.
Absolutely.
Yep. And it doesn't have to be like a quadruped or a humanoid robot, that's another question I will give you about the humanoid robots. But also self-driving cars. Like it could be intelligent systems where you communicate, interact with the car that, take him to one point to another point, and it will give you in the same time some vital signs, some situational awareness, some recommendation that there is some crash ahead of time. Would you mind if I will change my route to this?
Sure.
Give you, it will save time and this and that. We're talking about the intelligent systems. Could be really useful in that application. But going back now, the question for you, how close are we to widespread self-driving cars?
So my standard answer is typically kids born today will not have to drive a car.
Oh.
And you're seeing now Waymo is deploying self-driving cars in San Diego. So Bankers Hill, Old Town, sort of all of those areas, we will have autonomous driving Waymos within a month. So we'll start to see it. Zoox is deploying. So Las Vegas has 4 different providers. Austin has a number of providers. San Francisco. So we're getting there. And I'm sort of arguing that this will change the socioeconomics in terms of today, the second largest expense for most families are cars. I drive a really nice car, but most people look at me and say, my bank advisor look at me and said, "Are you stupid? Are you spending all that money on a nice car?" So I think in the future we will have a mobility service from A to B. You will drive from A to B, but you don't have to own that car. So I think we're very close. So it took us 15 years from the Urban Grand Challenge. It actually took us sort of 40 years. So the first autonomous driving car was Ernest Dickmann's from Germany, who drove it in 1984.
Oh wow.
So more
yeah.
more than 40 years ago, and he drove it on the German autobahn, at 150 kilometers an hour.
Oh my.
That was 40 years ago, and then it took a long time. It got to the U.S. We had a number of competitions, and now we're there. But I think we're very close to having this, and I think people are going to love it because. So I love driving a car. So I'm going, one of the last guys they're going to have to drag out of a car and say, "Stop doing this." But for most people, they want to get to work. They, can I read my email on my way to work? Can I plan what are we going to have for dinner? All of these things. So I think for most people, this will be a great relief.
Wow. Wow. Yes. Yes. Back in time. Wow.
Yeah.
That long time. Yeah.
Yeah.
This is amazing. Amazing. How things been evolved and developed.
Yep.
And it started a long time ago, but didn't take. Never happened to be like for the self-driving cars in 1984, but there was the people, the community, the science, the technology wasn't there all yet.
No.
It was one prototype to show.
So if you look at the Dickman's car, it was an old diesel truck, and the entire sort of luggage compartment was filled with computers. So it didn't quite, it had it was, 6 computer racks
Wow.
in the back of a Mercedes truck
Wow.
driving around, and at the time that was what we could do.
Yeah.
And then he was very proud. 10 years later, he drove in traffic, rush hour traffic in Paris. Rush hour traffic in Paris is, and then he was in another Mercedes, but it was a passenger car, and the trunk was filled with it. So he went from 6 computer racks to it could be in the trunk of a car, to today where, if you go to Qualcomm and look at their autonomous driving cars, it's a really small computer in the back of the car that can do all of it.
Now look, when we can see Qualcomm and even Tesla now.
Yeah.
Self-driving cars there's, which is very impressive.
Yeah.
And we don't see obvious like Waymo and others. They have a sensors outside the vehicle, but the Tesla doesn't have this exposed from the outside skin sensors. But I know you have your say there.
No, but at the same time, also I think if we look at the Zoox, the Waymos, all of those, I'm going to be sort of slapping myself a little bit in the back and saying, this is what happens if you let engineers drive the design. It looks like you're just like, really? A Christmas tree was what you...
Yeah.
So we, and I think that's important for a lot of the technology we talk about. We need people that sort of understands, how do we interact with people? So we need the cognitive science in this. We need the design people. It doesn't have to look like a Christmas tree. It could look like something like a Tesla.
Yeah.
And we need the engineers that can do it. But if you only let the engineers do it, it will look like the engineers.
Exactly. That is, yeah. So we need everyone. By the way, it's multidisciplinary problem, right?
Yeah. It's extremely important.
Yeah.
Yeah.
It's, you build a system that requires mechanical engineering, electrical engineering, software. Right. Yes, but not enough.
But to give you a small example, 20 years ago, we built it. One of my colleagues was a professor of human computer interaction. She had a walking disorder, so she had to wear crutches to be able to actually walk anywhere. And so we built a small robot for her that would get her coffee. So drive into the kitchen and beg and said, "Can I please get some coffee for Kirsten?"
No.
And people felt very uncomfortable with this robot driving around in the hallway. Is it going to be safe? Is it going to be? Then we put this small character on top that looked like a doll, and so very simple doll, and it would do things like it had head motion. It could say yes, it could say no, it could sort of raise its hand to get attention, and then we tried again, and people say, "Oh no, it's safe. There's a driver," and I said, "But it's made out of aluminum. It has an IQ of 0."
Yeah.
I said, "Oh, but it's safe." So that's where this design sort of comes in. How do we make people feel comfortable? That small character on top of it. So the question is, will our future cars have a small character that will sort of be...
It's like, I'm driving. When the head is shaking. Yes. It's
Who
incredible.
knows?
Yeah, yeah. Then it's psychology, art,
Yep.
and all that things. That's why robots are hard.
Yeah.
Yeah. Now, going back to the more like ethic questions,
Sure.
I remember when I took your class and you made sure the last or few lectures were about human robot ethics,
Right.
which is super important because we are not just building a software that runs on the computer, but we're building a physical identity interacting with a human. That triggers a lot of it. One of them is the security issues,
Sure.
privacy, and the trustworthy system. Is it trustworthy or not? And the biggest one, are those robotics and AI taking off our the jobs or society? What happened to our purpose as a human? So I give you like kind of 3, 4 questions in here
Sure.
to answer: privacy and trustworthy, security concerns, and the job replacement and ethics in general.
Sure. No, no. So I think that's extremely important for us as designers or inventors of these systems, that we really think about sort of what are the societal implications. I fought long and hard with my wife about having an Alexa in our home. And I said, no, I don't want Jeff Bezos to be listening in on everything that we do. I feel really scared about this. If you have teenagers, do you want, I have a system in there that's listening to everything that they do? Now they have cameras, and I've had that discussion. So the modern Roombas and vacuum cleaners that are coming out have a built-in camera. And I was talking to my wife and I was just saying, you are aware when it drives around in the bedroom and you're running around naked, it will take pictures of you. I could hack into the vacuum cleaner and figure out what do you look like in your Eve costume. I'm like, is that okay? And we've seen pictures on the internet of vacuum cleaners being hacked, and at the same time, I see sort of the Gen Z generation. They're like, it's not a big deal. I've already put everything on Instagram, and I'm like, but I feel uncomfortable. My
Yes.
85-year-old mother. Is it okay? So I feel we as systems designers have to take a leading role on making sure that we're respecting people's privacy.
Right.
We have to make sure what is being distributed. The same, every time I teach my class, I ask if anybody owns a Tesla. And there's always one or two, I own a Tesla, and said, okay. When you buy a Tesla, you have to sign sort of a privacy agreement and saying, it's okay that Tesla gets access to all your traffic data, all of your driving behavior and all of this, and they can use it. So I said, how many of you have read that agreement? Do you know what you gave Tesla access to? And so far, I've never met anybody that has read that agreement because, of course, it's 220 pages long. It was written by a lawyer. So you're like, yeah, okay, make it end. But where do I sign so I can go away from here?
Yep.
But I would be worried, if my insurance company knew my driving behavior, because they can monitor all your cameras. They can just say, he has a little bit of a heavy foot on I-5. He has a little bit. That
you can blame the Porsche for it.
But still, it's sort of, I just feel it's our responsibility to make sure that people go into this with open eyes, so that they really think about, what is appropriate. And then I think, we need to sort of figure out and make warnings to people who said, you are aware I'm recording you right now. And I'm sure with the new privacy, some, insurance company will come and say, I need Julian's driving record so I can see how he's driving when he's going home. And then they can come and say, I think we need to talk.
Yeah.
That's,
Yeah.
and I think most people are not aware of what they give away.
Yeah.
And that's dangerous. So and it shouldn't be buried in a 220-page sort of end user agreement. So I think we have a responsibility. At the same time, I would say as engineers, we're the wrong people. That was why I said early on, I need the social sciences people. So I used to be on the IEEE ethics committee. On this, we also had a priest from the Vatican. It's the only priest I've seen use Linux as his computer. But still, it was important. We had a priest from the Vatican. We had sort of philosophers. We had people that understood sort of economics, and we had engineers. But it was important they all had to be there, so that we can't leave it to engineers. That's not what they're good at.
Yeah, absolutely. We talked about it earlier we said it's multidisciplinary. Bring people with different specialties into topics, especially when the system is going to be around many
Right. Exactly.
expertise. Like this is going to be at home with the children, with elderlies, with school, in the battlefield, so in the first responders.
Right.
Especially about the system, to think that way.
But the same you can sort of think about to take it sort of the other side. So I don't think you can buy them anymore. Sony used to make these small dogs, the Aibos, that would sort of walk around in your home. And I had sort of a question of, if somebody's beating up that sort of Sony, is that okay? Because it could point to that people might also be molesting their animals and stuff like that. So I think we can say, it's a computer, it's okay. No, it's not okay. So I think it's very important that we need to look at the ethics. What is acceptable behavior and what is unacceptable behavior?
Right. And with that, it goes back now, shifting things to robots. Would you agree to give robots the decision authority in a critical environment like healthcare, defense?
So the short answer today is no. And I think for the longest time, we're not going to be willing to hand authority to these vehicles or to the robots. First of all, they're not reliable enough. There's still way too many decisions. But already now, as we're sort of seeing with the Zoox vehicles, as an example, the autonomous driving vehicles that are driving around in LA, there's no steering wheel. You've already handed away your autonomy. There is no steering wheel. You can't take over and sort of say, like, no, you enter a car. There is no steering wheel. Are you going to be okay with driving? That's a step in that direction. I think from a defense scenario, I think it'll take a long time before we will have people in the hierarchy that are going to say, press the button and say, go, do this. In some sense, we are starting to do some of that. If you look at intelligent weapons that are sort of doing targeting, that are doing course corrections and stuff on the way. So we're moving in that direction where we're starting to hand autonomy to weapons, to drones, so eventually I think it'll happen. But I would say for the most part today, we don't have the robustness and the reliability. And then I think we need to use it for a period of time so that people will say, yeah, this is good. I think Waymo has driven 5 million miles, and that will sort of say that's something where we could start thinking about trust.
Yeah, absolutely, which is very important, and mind-opening also to realize how much we should trust the system. I always have the system, cooperative system, man in the loop, man have the final call. But sometimes man is not available, or the mission doesn't require man in the loop.
But where are you? If, you have a four-legged robot, a Spot that walks around. How much authority are you willing to give to your Spot?
None. Maybe
you need more summer in.
Yeah. Some. It's some when this authorities is when going to minefield. It's like, I don't want to be like, okay, I'm doing X, Y, and Z. Do you want me to diffuse this? Like, yeah, just clear it out and do this. That is the authority in that specific environment, but not all the time. Human in the loop, I think, the wise thing to do as of today. But we don't know. Maybe in the future things will shift or change for better, of course. Or it could be for worse, but hopefully for better.
But I think we'll see this with current AI systems. We're sort of moving. So we had, if we think about a certain AI, we're sort of talking about 3 generations of AI right now. So we have sort of the old, very traditional, rule-based statistical AI. That was sort of AI 1.0. Then we got to sort of what we're seeing now with LLMs and deep learning, which we would call AI 2.0.
Okay.
And then we're just starting to see what we would call agentic AI, where the idea is that you would have a set of functionalities that are autonomous. So you can imagine your robot You will sort of tell it to sort of say, can you go to that tunnel? Can you search through the tunnel? Can you see what's in there? And each of those steps are carried out autonomously. You are still in charge of tasking the robot
Right.
with where you're going to go. But at the same time, you are in the loop. You can do sort of the supervision,
Right.
but it's not you with a
Still
gamepad
offering,
sort of
yes.
driving. So I think that will gradually get to a point where
Right.
we will be much more happy using this. So agentic AI is just starting out, and I think it's going to become a pretty big deal.
No, yeah, yeah, I agree. This is same. It's a scope of the.
But-
We are man in the loop in terms of the authority
Right,
and
but-
commanding.
But also, and I think it's sort of important. So many years ago, 25 years ago, I did sort of experiments with the Swedish army where we had packbots, where we've given autonomy, and we would deploy it with Special Operations Command in Sweden. And one of my PhD students was a major in the Swedish army, and they had not thought about this, that once you operate these, you lose situational awareness.
Oh yeah.
So we had,
Oh yeah.
so the best example I have of this was he was driving, he was giving sort of a demo, and I went up to him and I took sort of a flash photography of him, and then 2 seconds later he's like, "Oh, you have a camera? Can you take a picture of me?" I said, "I just did with flash." He said,
Wow.
"No,"
Yeah.
and then I showed him the picture, and he was like, "Uh-oh." And we've seen this when we did exercises. The guy who was the operator, the rest of the unit sort of moved along, and the guy was still sitting in the middle of a field, sort of, hey, where did my people go? And that's scary. That we had to have a person dedicated to keeping track of the operator. Once we get to sort of agentic, it will allow the operator to spend time on keeping track of operational awareness and all of these things, and it would bring much more safety to the responders.
Awesome. Now we're going back to
Sure.
the time machine, but this time, in the time machine, you will be the driver.
Okay.
You take us to your world for future, how you envision the future of robots, all platforms, and the intelligent systems. The goods and bads. A little bit of goods, a little bit of bads. Well, not the bads, the goods, and then the concern, I would say.
John. So I'm, of course, I'm a roboticist, so I'm very optimistic about the future, and I think we will use it to, we'll use it to improve our manufacturing, which we're already talking about. How do we bring back manufacturing? We are seeing a world that is aging significantly. We're not having enough kids, and because of this, we're seeing significant aging. We're going to use robots to give people autonomy to stay in their homes, so that they don't have to go to a managed care facility. They will actually be able to get support in their homes. I had long discussions with my mother about this. Right now, she gets sort of healthcare assistants at home. They come and they clean her apartment, and she's like, "I can clean my apartment. They should come sit down and talk to me." So she would rather that the human interaction is about her, not about, do you have a clean home? So we can get robots that will help you clean a home. So I'm sort of saying, I would like to have a robot that will allow me to get out of bed, take a shower, get dressed, prepare a meal, and participate in social activities.
Wow.
We don't have a robot today I'm going to shower with. I'm just telling you up front, and not happening, I'm not trusting robots for that. So I feel we need to get to a point where we can empower people to have quality of life from cradle to grave. And then in the work scenario, we should use the robots to empower people to take them as far away as possible from dangers. So it's more, whether it's in driving downtown LA, or it's going for an intervention in Iran, or wherever you go,
Right.
we should use the robots to do this. I used to work at Oak Ridge where we were looking for nuclear waste. I don't want people to go in and look for nuclear waste. I want the robots to go in nuclear waste. If we lose a robot, okay, we saved a life.
Yes.
So I think we're gonna see this of healthcare, manufacturing, logistics. So there's a lot of these things where I think it will become a very important technology for us to get a better quality of life.
Right.
That's not the same as saying we should become couch potatoes and sit at home and just watch television. But we should still live an active life so that we are healthy and all of these things. But at the same time, the dirty, dull, and dangerous we talked about earlier on, that should be replaced with robots.
Awesome. Well, this was amazing episode, and it was always fun to
Well,
talk
Thank you
to
for inviting me.
Absolutely. We are now a Pacific podcast. We are thrilled, and thank you very much. We appreciate you coming.